So the major approach is with regards to um, to do with checking. I mean, first thing first is that what we actually truly want to do over here is to actually get the outcome of like target equals to 9, right? So and there's this bunch of like numbers that we actually can do. So I mean, for one thing is for sure is that we can use this brute force way, which is by doing this sort of like n square method to actually go through every single pattern to find out what plus what equals to. So it's also involving a plus b, so to speak, to actually get the target value 9. And with regards to a second method that we can actually do, it's actually using the 2-pointer, which we actually talk a lot about during our previous. So with regards to that, we can then point ourselves to the z stage, which is coming from the previous, which is that we can have a conditional statement, and then it can be pointing towards the first method, which is to move 2 pointer at one go, or actually be able to just move 1 pointer at one time. So having the conditional do we move 2 pointer at one time, or like having 1 point to actually move at a time? So we're definitely leaning more towards B, which is the 1 point to move over. So if we were to actually zoom and dive deep into this scenario over here, which is that it's been sorted, obviously. So if you go towards the left side, you are actually minusing your values, and if you are going to the right side, you are plusing your values per se. So and you get to see that they actually play out the situation as we played many times before. So the first value was like obviously 12, because you do the first two values to be plus together, so it's smaller, so you want to minus, so you move your next pointer, which is this pointer, you move to here, and then you get 8, and that's when you want to plus the value, because your target value eventually is a 9, right? So and then you get a 10, right? So it's now more, so when you minus, you move the next pointer and so you get 8, so it's you need to plus, so you move towards here, and so just to rewind, at the very start it was like 1 and then the 11, which gives me 12, and we want to minus, therefore we move this to this route, and that gives us 8. We this time around we want to plus, so we move the left router, and so we get 10, and that's too big. We want minus, so we move this bad boy, gives us 8, and we want to plus, and so we shift the last one, and then that gives us 9. So that was like pretty much it for how we actually execute what we actually talk about, the micro details about how for one pointer to be executed in. So definitely at the very start video, it definitely did discuss about the brute force way, which is you find every single combination. That will be the intuitive way of like doing the problem. So what they do is that you have 1, and then you check all the combination for 1, and then what goes next is that you check for combination for 3, every single combination for 3, and then every combination for 4, every combination for 5, 7, 10, so on and so forth. So that's the brute force way, and I mean eventually you do am able to get the answer, which is very similar to here, which is the 4 and the 5 eventually, because in the 4 combination you definitely will run into 4 and 5, right? So and as you can see, brute force is definitely very tedious. It just runs through every single combination and as such. But for say, if I say a one pointer way of like doing things, it's so much more intuitive, and it's very easy to get answer within big O of n. Definitely you do see one is easy and the other is hard. So yeah, there you have it. Everything comes to an end.